Hey guys, we are back. We are moving on from equations, solving equations. We are now moving on to lesson 11.1, linear equations and slope. So this is something completely new, but we're still going to be doing guided notes, so make sure you follow along carefully and write down anything I write down. Let's mark up the learning target. Today we're going to be finding the rate of change from a graph. Finding the rate of change. Rate of change is also known as slope. You guys did a little bit of slope last year in 7th grade, but to find the slope of the line, it's the change in the y over the change in the x on 2 points on a graph. You might also hear slope called the constant rate of change. Every once in a while, it's referred to as the average rate of change. But all linear relationships have a constant rate of change. The word linear is very important. I want you to write that on your paper, linear, because you'll notice the word line in linear. Linear means straight line. All linear relations have a constant rate of change and will be a straight line. The slope tells you how steep or how flat a line is, and we'll talk later on about the y-intercept. But today we're going to be looking at slope from a graph and finding the slope from a graph. So to start, imagine that you go to a ski resort and they're selling lift tickets for $30. They're selling lift tickets for $30. What this really means is that for every 1 day, so you can really make this as 30 over 1, for every 1 day, the total cost that you'll pay for tickets will be $30 every day, each day per day. So we're going to fill out this table. On day number 0, obviously you haven't spent any money, so that's going to be 0. On day number 1, you've spent 30. On day number 2, you spent 60. You can see there's a pattern here. Every time it goes up by $30. And so day 4 is 120, day 5 is 150, and day 6 is 180. Now that we know the rate of change is $30 per 1 day, and maybe I'll even write day right here for you to see this is day. We're then going to plot this on the graph. So we're going from a rate of change, putting it in a table, and now we're going to do a graph. So whenever we do a graph, guys, it's important that we find the slope by having 2 points. Let's say these two are my 2 points, point W and point Z. You're always going to do the rise or the vertical change, the rise over the run or the horizontal change. So the vertical change is the change in the Y, and you can see from here to here that number is 6. And my change in X is this horizontal change, and that is going to be a change of 10. So that's just a little example on the side, but if we're going to plot this table onto the graph, we're going to go to where X is 0, Y is 0. So that first point that we're going to do is going to be right here on the center. So if you wanted to label that point A, that would be point A. This is 1 day. This is 1 day here. So I'm going to move that a little bit so you can see that's 1 day. So 0, 0. 1 day, $30 is just above this line, so there's the second point. 2 days is 60, which is approximately, let's say about right here. 3 days, 90, a little bit below 100. 4 days, 120. 5 days, 150. Oh, that's right on the corner, that's an easy one. 6 days, 180. And that's right here. Okay, and this would continue to go on the whole time. So we can go ahead and draw a straight line that goes through the origin, through all these points. If we extended this line out, it would continue to go up like that. This is a linear function. It's a straight line, linear function. Linear means straight line. And then if we wanted to find any slope using the points that are given here, all we would have to do is connect some 2 dots and do the rise over the run, paying attention to what the interval is over here. Let's look at a couple other real-world examples. So I'm going to do number 1A. Go ahead and switch the backside of your guided notes. I'll do number 1A. We're going to find the slope of number 1A. So what we have to do is use any of these points that are given here. You'll notice there's a lot of different points we can choose from. We're going to do the rise over the run. So an easy way to do this is to go ahead and connect these dots. And you really need to choose 2 of them, but I'll show you all the different points you can pick. Any 2 points you're going to connect, you're going to find the rise over the run. What you'll see here, this one's probably the easiest because it starts at 0 and it goes up to 50. So the rise is 50 In the run, pay close attention to the scale. It goes from 0 to 1 here, so that's just a run of 1. Same thing, rise 50, run 1, rise 50, run 1. So this one is the money earned tutoring. So every week you spend tutoring, it's looking like you're earning $50. $50 per every week would be the slope. So if we're going to write that, then in our answer, it'd be 50 over 1. And if you wanted to put labels with that then as well, it'd be $50 is what we're talking about here per week. I want you to try number 1b on your own. See if you can find the slope of this line when you're given these points here. Pay very close attention to what you're doing. This is Caitlin's earning per hour. So find the slope of that line right now. Press pause and try 1b on your own. Okay, let's find the slope of lines when all we have is the graph. So all you got to do is find points on the line. You'll remember this from 7th grade, but there's a point there. It has to be a corner point in order to find the slope, and it should be consistent. Since these are all yellows, we can use any of these lines here, and we can just find the rise over the run of any of these points, the rise of the run, or the vertical change over the horizontal change. So this one goes from 3 all the way up, it even looks like, to 1.5. That's interesting. It goes from 3 to 1.5. So this is a positive slope. Anything that goes uphill is a positive slope. So it goes from 3 to 1.5. This one goes from 1.5 to 0. So it looks like it's changing. The vertical change is 1.5. And the horizontal change is just, let's see, from half, this is 1 to 1/2. That's just 0.5. So then the slope would be 1.5 over 0.5. Or what else we could do, since we're using decimals, we find a different one. Let's say I use 2 points that are further away from each other. So I wanted to use this point here all the way up to there. That goes from 1.5 up to 1/2. So that's really a rise of 3. Oops, not 30. 3 over 1. So this slope is also equivalent to 3 over 1. The slope of this line is 3 over 1. Press pause and see if you can do number 2b on your own. Okay, let's look at 3a now. So for 3a, you'll notice this is a negative slope. It is going downhill from left to right. It's a negative slope. Again, we want to find points on the graph, so you'll notice that you're going to have to find these corner points right here. And these are the points we can choose from to find the slope of the line. So again, do the rise over the run. In this case, since our rise is going down, we're going down and over. So notice we go from 1 to 0. So that's a rise of 1. And this is a run of just 1/2, because -1, we're not even getting back to 0, so that's 1/2. All right, so let's try not to have decimals in here. So if we use 2 points that are further apart, let's say we did rise, down, run 1. So now you can see we go from 0 to -2, so that's a slope of -2. And we go from 1/2 to 1/2, that's a slope of 1 there. So the slope of this would be -2 over 1, which is just equal to -2. Press pause and do 3b on your own. Okay, for number 4, you'll notice this is another negative slope because it's going downhill. It's going downhill. So we're going to find different points we can use. There's a point there. There's a corner point there. There's a corner point there that has a coordinate. These are points that all have coordinates. We're going to find the slope of this. So you'll notice we can go rise, run. The rise goes down, which means it's a negative slope. Anything that goes down from left to right is a negative. So it goes from 4 to 2.5. 4 to 2.5, that is a difference of 1.5. Okay, we could also even do it bigger. So let's say I want to connect these 2 points. I'm going to use blue here so you can see. Actually, no, I'm going to use this one, 4, so you can see it really well. So go down from 4 all the way down to 1, and we're going to go over to this point here. So the 2 points I use is from here to here. it goes from 4 to 1. That's a slope of -3. And then the run is from 1 to 2. So this slope is going to be a -3 over 2. 3 over 2 would be the slope. Press pause and do 4b on your own. When you finish 4b, spend the rest of your time that you have remaining in class on IXL. You can find that IXL lesson on Canvas. Good luck.